Okay, today we're going to be talking about the Pythagorean Theorem. And the Pythagorean Theorem is a property that applies to right triangles, like this one. So by right triangle, what we mean is a triangle that has one right angle in it. And this little box here signifies that this is a right angle. So, let's just take a look at what this triangle is for just a second. So we have two legs. A and B are called legs, and they're called legs because they're they touch the right angle. And for the purposes of the Pythagorean theorem, A and B are interchangeable, but C is not. C is what we call the hypotenuse. C is the side that does not touch the right angle, and what the Pythagorean theorem does is it tells us the relationship between the lengths of A and B to the length of C. So let's go ahead and write out what the Pythagorean theorem is. It's a squared plus, not c, c squared, b squared equals c squared. So that means if we take the side length of A, square it, and add it to the square of the side length of B, then we'll get the square of the side length of C. So that means that if we have the side lengths of any two, we can find the side length of the third. So let's go ahead and deal with an example. So this is the most basic concept. This is what we're going for. This section is pretty easy as long as you understand exactly what this is. C is always the hypotenuse. It's always the side opposite of the right angle. Okay, so I'm sure you've all seen this internet joke, find x, here it is. Okay, well we're actually going to go ahead and do this example. We're going to solve it. Because this is actually a classic Pythagorean theorem problem. Okay, so what we're going to do is we're going to take what we know and put it into the theorem. So let's say we have that A is equal to 4 centimeters. We're going to go ahead and ignore the centimeters for now, though, just because it's easier to deal with it that way. So 4 centimeters, or 4 squared. Oh, just a second. Okay, here we go. Let's take a little less room. Okay, so 4 squared plus, because 4 is A, so 4 is A. And let's also deal with B. B is 3, so we have 4 squared plus 3 squared. And X equals C, so X is equal to C. So X squared. More often than not, we're actually not going to bother putting a separate variable in for one of these, but for this case, just because I wanted to do this problem, we're going to go ahead and do it. So 4 squared plus 3 squared, that's going to be 16 plus 9 equals x squared. We're still solving for x squared, so we don't know what that's going to be yet. So 16 plus 9 is going to be 25 equals x squared. And so that means that x is equal to 5. Okay, let's go ahead and scroll down just a little bit. Okay, so you may be wondering, why is it that x is equal to 5 and not plus or minus 5? Usually when we take the square root of both sides like this, we have x equals plus or minus 5. But this is the exception to that rule, and the reason why is because we're finding a distance here. We're finding a length. And x cannot be, this triangle cannot be a negative length. So we just, in this particular case, we skip the plus or minus and just go straight to x equals 5, because x can't equal negative 5. Okay, so that is the classic Pythagorean theorem problem. Now let's go to a variation on that classic problem. So let's go ahead and get rid of this. We're going to do something very similar, but not exactly the same. Let's say that, for example, if we have that b is equal to 3 and 5 is equal to c. Oh, gotta scroll down. For example, b is equal to 3, 5 is equal to c. I'm going to go ahead and put up the, remember, a squared plus b squared equals c squared. Oh, I didn't even put that out of order. C equals 5. So b equals 3, c equals 5. Find a. So we know what b is, we know what c is, but we don't know what a is. So to fix that, what we're going to do is we're going to put everything that we know into the equation. So we don't know what a is, so we're just going to put a squared for a. So then we do know what b is, though, so we can put 3 in for b. So it's a squared plus 3 squared equals, and we do know what c is. It's 5, so equals 5 squared. So a squared plus 9 equals 25, or a squared, I'm going to go ahead and write out that intermediate step 2, equals 25. A squared plus 9 equals 25, and a squared equals 16. So for this, I went ahead and subtracted 9 from both sides, and then I got a squared equals 16. Well, the square root of 16, remember, we don't need to do plus or minus the square root because we're talking about a distance. A is, just like c, a distance or length. So we have a equals 4. So we've found a. A is equal to 4. And that is going to be our final answer. Now, of course, you're not always going to get such clear, easy solutions like this. I started this out as a started out using this problem because I wanted to get something that's easy to work with. And also notice, remember I said before, this is a variation of the classic problem. This is actually the same triangle that we had in the first example, but it is it's instead of looking for C, we're looking for A. Now let's go ahead and clear all that stuff off. But now let's take an example where we don't have something that's quite so easily found. Something that's, well, actually it's pretty easily found, but the answer doesn't look so clean, doesn't look so pretty. So let's say that A is equal to 1 and B is equal to 1. So we need to find C. Oh, whoops, just a second. Okay, so A is equal to 1 and B is equal to 1, and we need to find C. This is going to give us a different kind of answer. It's going to give us an irrational answer. So let's say let's go ahead and plug it straight in. We have that, I'm going to write this over here, so just so you can keep it, A squared plus B squared, hope I can fit this on there, equals C squared. Okay, it fits. A squared plus B squared equals C squared. So we have that A is equal to 1. So we can say that we have 1 squared. B's over here is equal to 1. So we have plus 1 squared. And C is unknown. We don't know what C is yet. So is equal to C squared. Okay, so what is 1 squared plus 1 squared? Well, 1 squared is 1, so 1 plus 1 will give you 2. So 1 plus 1 will give you 2 equals C squared. So, since we have 2 equals C squared, let's go ahead and take the square root of both sides. And of course, just like before, even though this is going to give us an irrational number, we still keep off the plus or minus. So c equals square root of 2. Okay, so this is going to be our final answer, because you can't simplify the square root of 2 any further. And this problem is very significant because this is actually the problem where irrational numbers were first discovered by the Greeks about 2,400 years ago, by the Pythagoreans, in fact. Okay, so now let's go ahead and erase all this. I want to keep this here, which is why I'm not just clearing it all off. Okay, so we have that c equals root 2 is our final answer for this case, and that's because we didn't get such a easy answer. Let's go to another example. Let's say we have b equals 5 and c equals 10. Find a. So b squared, let's go straight from left to right. You don't have to, but just, whatever works. In this case, a, do we know what a is? No, we don't. We're trying to find a. So we can say that this is equal to a squared. And then b, do we know what b is? Yeah, b is 5. So we can put 5 straight in for b. So plus 5 squared. Do we know what c is? Yeah, we know that c is equal to 10. So equals 10 squared. Okay, so now I'm going to go ahead and scroll down a little bit so I have a little bit more room. Okay, so it's not too hard to deal with this from here. We can go ahead and rewrite this as a squared plus 25 plus 100. And then 100, oops, not plus. Okay, a squared plus 25 equals 100. And so that means we can subtract 25 from both sides to get a squared equals 75. Take the square root of both sides. Doesn't look too neat, but we have a equals square root of 75. So 75, that's going to be 3 times 25. 25 is going to be 5 times 5. So we have two 5s that we can pair up, and 1 3 is going to be left back underneath the radical. So we have that a is equal to 5 square root of 3. So 5 root 3 is the side length of a. This is another example, an even better example, where your side length is even more unusual. It's not going to give you a clean number like just 4 or something. It's going to give you 5 square root of 3. Okay, let's do one more example. And this is something that I don't want to finish it. I just want to, let's go ahead and clear all it off, and I'll just rewrite this part. A squared plus b squared. This is also something that's pretty good to have memorized. You're not going to come across it all the time or anything like that, but you will come across it in trig quite a bit. So it's not nearly as common as the quadratic equation, but it's still something that's good to know, good to have memorized. And it's not that hard to memorize either. It's a squared plus b squared equals c squared. Okay, so let's do one more example. I don't want to finish this, I want to just get it started. So let's say, what if c is equal to 15 and a is equal to 2 times b? So now we have something different. We don't have that A is equal to some number. We have that we know that A is twice as much as B. That's all we're told. So find B and A. So we have two unknowns, but we have some information about those two unknowns that we could use to our advantage. What we can do is we can write this A in terms of 2B. So let's say we have A squared. Well, we don't know what A is except that it is twice as much as B. So let's just rewrite it as 2B. Instead of A squared, we have 2 times B squared. This A squared is 2 times B. Don't forget to put the parentheses around it. So then we know nothing. We don't know what B is. We don't have it in terms of anything. So we just write it plus B squared equals. We know that C is equal to 15. So 15 squared. So now what we have is we have an equation that has one unknown. Notice that there are no A's in here. There's only one unknown, and that's B. So we can use this equation to find out what B is. Then we can find out what A is, because we'll just multiply B by 2 to get A. So, like I said, I don't want to finish this. This is as far as I want to go, but this should get you to the point where you should be able to figure out how to do this problem. And that concludes this video. This is a short section. I will see you in the next video.